recorded. Okay. The next little bit in this chapter is about valid patterns of deductive reasoning. And there's a question on big X with regard to these patterns. So if you look at each one of these, they're like legal moves that you could make in a proof or an argument. For example, this first one says, if you know that P implies Q and you know that P is true, then you definitely know that Q is true. This is like saying, okay, if it's snowing, then it's cold. We know it's snowing, therefore it's cold. So if you knew that if it's snowing, then it's cold, and you know it's snowing, then you could conclude that it's cold. And on the other hand, though, if you knew that if it's snowing, then it's cold, then if you say, okay, well, I know it's not cold, therefore you can conclude it can't be snowing. Now that depends on these implications being true, but this is sort of like saying, okay, you can either affirm the premise and get a true statement, or you can deny the conclusion and get a different kind of true statement. So I've given these names are non-standard, but they sort of describe the logic here. And some of these have like Latin names from ages ago, but there's no point in learning those. Okay, this one's a little different. It says if P implies Q and Q implies R, then P implies R. So if P guarantees the truth of Q, and Q guarantees the truth of R, then P is actually going to guarantee the truth of R. You sort of skip the middle step here in the logic. Common outcome. If either P is true or Q is true, and P implies R, and Q implies R, then you know R is true because, well, we only have two alternatives, P or Q. And in both cases, they imply another result R. Well, that results R has got to be true because it doesn't matter whether P is true or Q is true. So all of these are ways that the people actually think like, and you actually probably intuitively, may not be aware, actually use these patterns of reasoning just to think through things that happen in everyday life. Although you may not be aware of it. Okay. So then there's a few other ones that are like also maybe not so useful. Or this first one is, but okay, if P or Q is true and P is one of the options is not true, the other one's got to be true. That is, if you know that like if you know it's either raining or it's snowing, and it's not raining, then you know it's got to be snowing. So it's like saying, okay, it's either A or B. If it's not A, it's got to be B. So that's what this first, and this one was the one that we used in the proof above. If it is raining and it is cold, then you can conclude that it's raining. And if you know it's raining and it's cold, you could also conclude that it's cold. You can sort of take apart each one of these. And we use this in the linear systems one. You can also create an alternative. If P is true, then either P or Q is true, no matter what Q is. And the same with the other way around. And also if P is true and Q is true, then both P and Q is true. These last three are more of use sort of making steps and proofs. Okay, so these are just patterns that here's another pattern. To prove that something's unique, you assume that there's two such entities and prove they're the same. Maybe I've overplayed my hand here and given you all this talking, so I should probably stop and we'll come back to some of this later. That sort of goes over some of those. There's some questions on Big X that deal with those proof patterns. Those are all patterns that are not only used in arguments, but are used to organize proofs sometimes. This may sound more forbidding than it is, but so that's all I wanted to say about chapter 0 stuff. Now, the acclimatization problems on Rig X here are due this coming Sunday night, and they involve a lot of the chapter 0 stuff that we've gone over already. So what you want to do is look over those and make sure that you sort of like attempt answers, and then if you're unsure about it, ask me in class on Thursday or later today or in office hours. And that way you can sort of like maximize your getting right answers. Any questions now about any of this stuff? If not, then it's back to linear systems and Gauss's method. Okay. Let us, let's see.